We're going to work on the in-class review. This was what we did in class to review. And then the other side of your paper, you have as work on your own. You had the rest of class and that night to work on it. So the first thing we're going to do is up at the top, the conversions. Remember, you figure out how many places you walk, and the number of places you walk in that direction is where you move the decimal point. So the first one, we go from centiliter to decaliter. So we're going from here to here. That's 1, 2, 3. That's 3 steps this direction. So I'm going to move my decimal point 1, 2, 3, and I get 0.2368. So 236.8 centiliters is equal to 0.2368 decaliters. All right, so kilometers to decimeters are going from here to here. That's 1, 2, 3, 4. That's 4 steps that way. So I'm going to take this decimal point, 1, 2, 3, 4, and end up with 3.5. So this number and this number are equal. 5 grams. I'm going from grams to centa. That's 1, 2. That's 2 steps in this direction. My invisible decimal point's right there. I don't have anything to move around, so I have to add 2 zeros. And I get 500. You could have 500 or 500 point, I suppose. Milliliters to deciliters. Milli to deci, that's 1, 2. It's 2 steps that direction. My invisible decimal point is behind the 7 right here. I can move once around the 7, once around the 4, and I get 4, 7. The next one, I'm going centa to hecta. Centa to hecta, 1, 2, 3, 4. That's 4 steps in that direction. I can't move 4, I can only move 2, so I have to add 2 zeros. That's how easy this is, which means you can convert any metric unit into any other metric unit already. All right, these are formulas, and they're word problems. The formula for volume is a cube. If all sides of the cube are 3.42 centimeters, what is that cube's volume? Sorry, there's a typo in there. 3.42 centimeters. The formula is LWH, L times W times H. All sides of the cube are the same size, so it'd be 3.42 centimeters times 3.42 centimeters times 3.42 centimeters. Now remember, you have to write the centimeters. I've rewritten the formula with the numbers and units in it, meaning the numbers and the units. If you don't put the units in, you're not going to get points for the rewrite. Okay, I multiply that together and I get 40.001688. Now I got to figure out what to round it to. Again, you don't have to write this number out. If you want to round it off your calculator, that's fine. I'm going to write it just so people on this video can see it. I got 2 decimal places on this measurement. I've got 2 decimal places on this measurement. I've got 2 decimal places on this measurement. So the least number of decimal places is 2. So I got to round to 2, which is this 0 right here. That is my second decimal place in my answer. The 1 makes that 0 stay the same. So my final answer is 40.00. And yes, you must have the 00 because that shows how accurately you measured. Then you took centimeters times centimeters times centimeters. So it'd be centimeters cubed, a little 3 up there. You are moving a big box. How much power will it take to move it if it has a mass of 147.2 kilograms and you are moving at 250 meters and 300 seconds? Okay, so the formula is right here, md divided by t. So m is mass of 147.2 kilograms times d is 250 meters. And by the way, all the units in one problem would have to all either be metrics or all are units. You couldn't mix them. Over t, which is 300.0 seconds. All right, so I'm going to take 142 kilograms times 250 divided by 300.0. and I get 122.66. Now, this number has one decimal place. This measurement has one decimal place. This measurement has no decimal places. This measurement has one. So the least number of decimal places is none. So I got to move over here to the number that represents the last number before none, which is this 2. The 6 makes the 2 go up. So my final rounded answer is 123. I've got kilograms on top, meters on top, seconds on bottom. None of them are alike, so I have no chance of canceling any out. So I got to keep them. Kilograms on top, meters on top, seconds on bottom. Just that simple. You're on an airplane to Nashville, Tennessee. Your trip, and sorry about the other typo, your trip has this distance, and it takes this much time. What was the average speed if you take distance divided by time? So I'm going to put distance on top. 462.7 kilometers. And again, I'm keeping my units with it. And over that, under that, I'm going to put the time, which was 0.7 hours. So I'm going to take 462.7 divided by 0.7, and I get 661. Actually, I get 661. But I have one decimal place and one decimal place in the measurements of my problem. So my least number of decimal places is 1. So my answer has to have 1. So I have to add that 0. And if you put it, by the way, on this one, we had a lot of trouble with people using fractions. If the formula says a fraction, you need to write it like a fraction. If you do, it'll give you your units, kilometers per hour. Then the next one, you accidentally drop your phone over the side of a cruise ship. Oh, wah, wah, wah. Anyway, it falls for 48 seconds. How far will it fall if distance equal gravity times time? Well, it gives you gravity. Gravity is 9.8 meters per second. Times time, 48 seconds. And note, it says GT, so I put G first, then T. I don't make it backwards. I also, when I'll get my units, that could matter, not on this particular problem. But I'm going to take 9.8 times 48, and I get 470.4. This number, though, has no decimal digits. It's the least number of decimal digits in a measurement in my problem. Since it has none, my answer needs none. So the 4 does not make the, this is my last non-decimal digit. The 4 makes the 0 stay the same, so my answer is 470. I have meters on top, I have seconds on bottom. Remember, when you have a unit that's not a fraction, you pretend it's on top. So I have meters on top, seconds on bottom, seconds on top. I have seconds twice. If one is on the bottom and one is on the top, you can cancel them out, which is the case. So I get rid of seconds, and I'm left with meters, which makes sense because the formula asks for distance, and meters is a distance. What is the volume of a cylinder? Here's your radius. There's your height. If the formula is pi times diameter squared divided by 4. Now, the problem is it gives you radius, but it wants diameter. Well, radius we know, because on a circle, the diameter is all the way across, and the radius is from the center across. So all you really need to do is multiply your radius times 2. 2, by the way, is not a measurement, so it's not going to mess with our decimal places. 27.5 times 2, and I get 55, but I would make it 55.0 centimeters, my diameter. So then when I put it in my formula, I got 3.14 times diameter twice. 55.0 centimeters times 55.0 centimeters divided by 4 times h, which is 200.5 centimeters. Now, since all of this is multiply and divide, order of operations says you can do it in any order you want. The commutative property says so too. So I usually take 3.14 times 55 divided by 4 times 200.5, and I get this ridiculously long number, 476,112.3125. This is not a measurement, so it doesn't count when we're counting measurement, neither is the 4. So just the 255.0s and this, and they all have 1 decimal place. So I have to, my least number of decimal places is 1, so I'm going to round to this 3. The 1 makes the 3 stay the same, so my final number answer is 476,112.3. I'm going to put commas in there. It only takes 1. I took centimeters times centimeters times centimeters, so it's centimeters cubed. Have a lot of trouble with people writing 55 centimeters and just putting a 2 up there somewhere, and then they only get a square here. You've got to write this out and write all the units in, or you're going to get the wrong unit. All right, now it's time to start on the back.